Hello and welcome to Mr. Tompkins EdTech and a brand new series of videos aimed at helping you prepare for your GCSE mathematics exams. In this series I'll be giving a complete walkthrough of the GCSE mathematics practice papers to help you prepare for your exams this summer. Now there are not so many of these and you don't want to squander them, so make sure you try the paper yourself first before you look at these solutions. This particular paper is AQA June 2022, Paper 3, Higher Tier. Check the front cover of your paper to make sure it's the same one. If it's not, have a look through the playlist linked above, which includes all the GCSE Maths video walkthroughs I've recorded so far. I'm busy recording all of the GCSE practice papers, so if the one you're looking for isn't there already, why not subscribe by clicking the big red button below and check back in a few days. Don't forget to click on the bell so that you'll get a notification when I upload the next paper. I'll put timestamps in the description below, so you can choose to watch the whole thing through, or you can click on the timestamp and jump to the particular question you need help with. If you have a question, check the comments below, as someone else might have already asked the same thing. If it's a new question, leave it in the comments and I will try and answer all of them as soon as I can. Don't forget to mention which question on the paper you're referring to and try and be as specific as possible. Finally, if this video helps you with your revision, please give it a thumbs up. It will really help me out, and why not share the link with your friends, because they might need a helping hand too. Okay, let's get into it. Question 1, circle the smallest number. Okay. Well, before we do that, I just noticed that one of them is a recurring decimal, so I'm just going to write some more of its digits underneath, so we can actually see what it is that we're comparing, and so on. So not 4.3 with a dot on the top is 4.333333. Carry on forever. And then let's compare these numbers then. So when comparing numbers, it's a good idea to compare, like with like. So we're going to start with the biggest digit that's in each of the numbers, which is the units. And you can see this has got a 4 as its unit, this has got a 4, this has got a 4, and this has got a 4. So far, so much the same. Next digit along, I've got in the tenths column, I've got 3/10, 3/10, 3/10, 3/10. So that's all still the same. Next digit along, the 100th digit, I've got 100th, 300ths, 000ths, and 300ths. So I can see straight away then that that one there is going to be my smallest number. It's 4.301. Question 2, work out -4, 8 minus 3, -2. These are column vectors, aren't they? Okay, and when you're subtracting column vectors, you have to kind of subtract like with like. So I'm going to do -4 subtract 3. So what's -4 subtract 3? -4 subtract 3 is -7. So this is going to be equal to -7 on the top. And then subtracting the bottom one, so 8 subtract -2. When you take away a negative, it's the same as adding, isn't it? So 8 subtract -2 is the same thing as 8 plus 2. That's going to be 10. So the column vector I'm looking for is -7, 10. It's that one there, it's the first one. Question 3, here are 4 scatter graphs. We've got graph A, B, C, and D. Then part A says, for which graph is a straight line of best fit appropriate? Circle your answer. Okay, well there's only one here that's got a straight line of best fit, and that's going to be D, isn't it? It's got negative correlation sloping downwards like that. Okay, so we're going to have a better line of best fit, something like that. All the other ones have not got a straight line, have they? C, well there is no correlation by looks of things in C. B, it's kind of like that, isn't it? It's kind of tailing off, and with A it kind of goes up and then comes back down again. So yeah, there's only one with a straight line, and that is going to be D. Okay, so that's the one we want. B, which graph has one outlier? Circle your answer. Okay, well, one outlier. Well, C has just got bazillions of outliers. D are all pretty much in a line like little soldiers. Graph A, all of them seem to be following the same pattern. It's only really graph B that has a bilinomates, and that's that one there, isn't it? Okay, so it's going to be graph B that has one outlier. Question 4, use trigonometry to work out the size of angle X. Okay, So this looks like a job for SOHCAHTOA, isn't it? Okay, we've got a right angled triangle. So we're going to be using either the sine, cosine or tangent, depending on which sides we've been given and which ones are missing. So let's have a look what we've got here then. So we've got angle X marked here, and we've been given the opposite side over here. So this is the op. And we've been given the adjacent side over here, haven't we? So this is the adjacent side, okay? Now this side over here, the hypotenuse, we're not really that interested in it because we don't know what it is and we don't want to find it. So any of our ratios that have got the hypotenuse in it are not the ones we want. So I don't want the sine because it's got a h in it. I don't want the cosine because it's got a h in it. It's going to be this one on the end, isn't it? It's TOA, tan, that we want, okay? So I'm going to write down the trigonometric identity for tan. Tan theta equals op over adj, okay? The tangent of the angle is equal to the opposite side divided by its adjacent side. And then we're going to sub in what we know, okay? So it's not theta here, it's x. So tan x equals the opposite, which is 10, divided by the adjacent, which is 4, okay? So this is one of the ones where I need to find the angle. So I'm going to be using the inverse tangent of I tan to the -1 of whatever that fraction is there, of 10 quarters. Okay, so I'm going to reach for the calculator. I'm going to type in shift and then the tan key, so I can get tan to the -1. And then I'm going to type that fraction in, 10 over 4. And that's going to give me the answer, which is 68.2 to the nearest degree. So that's equal to 68.2 degrees. Before you move on, does it look reasonable? Does X look like a 70-degree angle? Yeah, it pretty much does. Okay, so I'm pretty happy with that. Question 5, Laura works in a shop. The table shows the number of hours she works on 2 weekends. So we've got weekend 1, weekend 2, and we've got Saturday and Sunday. So it's a bit of a two-way table going on here. Work out the percentage increase in her total hours from weekend 1 to weekend 2. Right, so we want to work out the percentage increase in her total hours going from weekend 1 to weekend 2. Okay, so we need to work out what those are then, don't we? We need to work out how many hours she worked in weekend 1 and how many hours she worked in weekend 2, and then we're going to have to find the percentage change. Okay, so let's work out the total hours for weekend 1 and weekend 2 first. So we need a total. Okay, so I'm just going to add an extra column on the end of my table here. So for weekend 1, I worked 3 hours and 2 hours, so that, or Laura did, so that's 5 hours altogether. And then for weekend 2, it's 5.5 and 3.5. That adds up to 9 hours, isn't it? Okay, okay. So right, now we need to do a percentage change question, isn't it? So I like to do these with a little triangle. Final, original, multiplier. So my method involves just identifying what these three things are from the question and then popping it into the formula and working through to the answer. Okay, so we want the percentage increase. Now the percentage increase is, well, it's the multiplier one, isn't it? The multiplier is the percentage written as a decimal. So we want to find that one. That's the one we don't know. Okay, and that's the one we want to find. Okay, now the final is the amount after the percentage increase has taken place. So here week 2 happens after week 1, so the final is going to be like the week 1 amount, a week 2 amount, which is 9 hours, isn't it? So that's 9 hours. Okay, and then the original was the original amount of hours, and that is the amount for week 1, which is 5 then, isn't it? So that's going to be 5 hours. Okay, and the 9 was the green one, wasn't it? Okay, so now I know the final and the original, I can then easily find the multiplier. Put my thumb on the one I want to find, cover it up, and then that tells me that the multiplier is equal to the final divided by the original. So multiplier equals final divided by original. And that is equal to, what's that? That's final 9 divided by original 5. So I'll type that into the calculator. 9 divided by 5, that comes out to be 1.8. Now remember, that's as a decimal, isn't it? So if I want that as a percentage, that is going to be 180% as a percentage. Okay, but that doesn't tell me the percentage increase. Now whenever you've got a percentage increase, you always start with 100%. So if I started with 100% and I've now got 180%, that means that the percentage increased by 80%, which took my 100% up to 180%. Okay, and that's my final answer. So the number of hours increased by 80% from week 1 to week 2. Question 6, here is a sketch of a curve y equals x squared minus 4x minus 5. And we've got the graph, it's showing me the roots, I've got the y-intercept, and I've got a point T, which I'm guessing is the turning point or the lowest point on the curve. Now it says write down the two roots of x squared minus 4x minus 5 equals 0. Now the roots are where it passes through the x-axis, and I can see there then that the roots there are at -1 and at 5. Okay, so the roots are -1 and 5. Part B says work out the coordinates of t, the turning point of the curve. Okay, now to find the turning point we need to complete the square, don't we? So I'm starting with y equals x squared minus 4x minus 5, and I'm going to rewrite it in the form of x plus or minus something all squared plus or minus something on the end. Okay, now that number that goes here is always half of this one here, so we take that one and we halve it, and that's what goes inside the bracket. So I'm going to get x minus 2 all squared. Okay, now that minus 5 that's there is still going to be on the end because I haven't dealt with that yet, but x minus 2 all squared is not a perfect replacement of x squared minus 4x. It's actually x squared minus 4x plus 4, so I need to take off 4 from that bracket to actually make it equal to the thing that's above. Okay, because at the moment this thing and this thing are not quite equal. Okay, it's -4 more, the second thing, than it is than the first thing, so I have to take it off so it balances back out again. Okay, so once I got that, I can just tidy it up. X minus 2 all squared minus 4 minus 5, that makes -9. Okay, so that's my equation in completed square form. So the lowest point, or the turning point, is going to be where that amount is the lowest value it can be, and that is going to be when the bracket part is equal to 0. And that occurs when x is equal to 2. So if you make x equals 2, then you get 2 minus 2 is equal to 0, and 0 squared is the lowest value that you can have, because when you square something, you always get a positive number, so the very least it can be is 0, and that occurs when x is 2. And when x is 2, then the first bracket will disappear, and you'll end up with y is equal to -9. Okay, so an easy way of thinking about it is the x value is just a negative version of that number up there, and the y value is the one on the end. Okay, that's all you get. So it's going to be at 2 minus 9 basically. So what is the coordinates of t? T has got the coordinates 2, -9. Question 7. A is an arithmetic progression. Here are the first 4 terms. So it's going 13, 16, 19, 22. G is a geometric progression. Here are the first 4 terms. It's going 2, 4, 8, 16. The nth term of A is equal to the 8th term of G. Work out the value of n. Okay, so what I'm going to do here is I'm going to find the nth term of each expression, and so then I can compare those a bit later on and hopefully solve for n. Okay, so let's do that then. So the nth term of the first sequence, can you see it's going up in +3s, isn't it? Okay, +3, +3, +3. So the nth term is going to have something to do with, I suppose we should call it, this is A, isn't it? So let's call it an. An, the nth term of A, is going to be equal to 3n plus what? Well, 3n would be 3, 6, 9, 12, and I've got 13, 16, 19, 22, which is, they're all 10 more than those values, aren't they? So the nth term of A is going to be an equals 3n plus 10. Okay. Now, the nth term of a geometric progression is equal to the first term, which is a, times the common ratio. What's the common ratio here? 4 is twice as big as 2. 8 is twice as big as 4. So R, the common ratio, is 2. So the general form of a geometric progression, nth term, is going to be a times r to the power of n minus 1. It's just a thing that you need to learn. Then subbing in our two values for a and r. A is 2, r is 2. So I get 2 times 2n to the minus 1, which you could simplify as, because I've got a 2 times 2 n to the minus 1, and that's the same thing as 2 to the power of n. Okay, it doesn't really matter because we're gonna sub that out in a minute anyway. Okay, so then the next part says the nth term of a is equal to the 8th term of g. Okay, so let's just find the 8th term of g, g8. That's going to be 2 to the power of 8, or it's 2 times 2 to the power of 7, which is 2 to the power of 8. If I just stack with the original thing, and that thing there that is confusing you. But anyway, that's 2 to the power of 8. What's that? 2 to the power of 8 calculator. I could do it on my hands, but hey ho, got a calculator. 2 to the power of 8, that's 256. Okay, so then I know that my nth term of a, 3n plus 10, is equal to my 8th term of g, which is 256. So now I can solve for n, can't I? Taking 10 away from both sides, that's going to give me 3n is equal to 246, and then dividing both sides by 3 then. So 246 divided by 3, that comes out to be 82. So it's the 82nd term of a, which is equal to the 8th term of g. So geometric progressions get big very quickly. So I had to go quite a long way along the arithmetic one to get that high as the 8th term of the geo. Okay, so n is 82, job done. Question 8, information about two fridge freezers A and B is shown. Okay, so we've got fridge A, which is a fridge freezer, total capacity of 330 litres, and the fridge capacity to the freezer capacity is 3 to 2. And we've got fridge B. It's got a fridge capacity of 294, so slightly less. The fridge capacity to the freezer capacity is 7 to 3. Okay, you can see the looks like the freezer capacity is slightly smaller compared to its rival over there. Grace buys one of these fridge freezers. She buys one with the greater freezer capacity. Which one does she buy? You must show your working. Okay, so is this one, which is deceptively not drawn to scale, have a bigger fridge freezer capacity than, oh no, it's the other way around. Oh yeah. So which one of these beasts here is going to have the highest freezing capacity? Let's work it out. Okay, it's basically a division divided by a ratio question, isn't it? Because I've got, for each of them, I know how much they each contain, and for each of them I've been given a ratio. So if I can divide those amounts by those ratios, I should get the fridge capacity and the freezer capacity, shouldn't I? Okay, now dividing by a ratio is pretty easy. Just take the original ratio and add the two bits together. So 3 plus 2, that's equal to 5, isn't it? 3 plus 2 is 5. Okay, so that means there are 3 shares and 2 shares, being 5 shares altogether. If you divide 330 by the number of shares, you should find the value of each share then. So 330 divided by 5, that tells me that the value of each share is 66, in this case litres. So then if I then take that original ratio 3 to 2 and I scale it up by a factor of 66, it should give me the capacity of each part of the fridge. Okay, so the fridgey part is going to be 3 times 66. 3 times 66, that is 198. 198. And the freezery bit is going to be 2 times 66, which comes out to be 132. Okay, do the same thing for the second one. For fridge B, notice that fridge is in bold here. So this one is set out slightly differently. In the first part we were given the total amount, so we needed to divide by ratio. But here we've been given the capacity of the fridge part. So if I write the ratio of the fridge part to the freezer part as 7:3, we now know that the fridge capacity is 294. Okay, so what we need to know is how many times 7 goes into 294. So if I type into the calculator 294 divided by 7, I get the answer 42. So I'm scaling up this ratio by a factor of 42. So if I'm doing that to the left-hand side, I need to do it with the freezer capacity side as well, don't I? So if I times that by 42 as well, then 3 times 42, that's 126, isn't it? 126. Okay, so which one do we want? We want the one with the greater freezer capacity. Which one has got the biggest freezer capacity? Well, this one has got a freezer capacity of 132. This one has a freezer capacity of 126. So no competition. Fridge A wins. So which one do we want? Fridge A has biggest freezer capacity. Question 9. Tom and Adil are the two runners in a 200-meter race. Tom completes the race in 24 seconds. Adil completes the race at an average speed of 28.8 kilometers per hour. Who wins the race? You must show your working. Okay, well, I guess the person who wins the race is the person who runs it in the shortest amount of time. Now, Tom completes the race in 24 seconds, and we know it's a 200-meter race. Adil completes the race at an average speed of 28.8 kilometers per hour, so we should be able to work out the time it takes because we know the distance that he ran. It was a 200-meter race, and we know the speed he ran it at. Okay, so the only thing we don't know is time there, isn't it? So using the DST triangle, distance, speed, time. If you hadn't noticed, they're alphabetical from top to bottom, so it should be easy for you to remember which way around it goes. And then see if we can identify what D is, what S is, what T is. Well, the distance is the distance traveled, isn't it? Which in this case is 200 meters. It's the value that we had up there. The speed is 28.8 kilometers per hour, which is we got from there. And so the only thing that we don't know then is time, and that is the thing we're trying to find, isn't it? How long it took him to run the race. So covering up T, that tells me that time is distance divided by speed. So time equals distance divided by speed. Now the distance was 200. A slight issue here in that we got different units, haven't we? Okay, so in order to sub in meters and kilometers, probably best idea to convert that into kilometers first before we go any further. So I'm going to say, well, 200 meters, that's the same thing as how many kilometers then? So there is 1,000 meters in a kilometer. So 200 meters is going to be 0.2 of a kilometer then, isn't it? Okay, so I'm going to rewrite that one as 0.2. So then my units all match. Okay, so I've got 0.2 kilometers. So 0.2 divided by 28.8. What's that then? That's a very short time in hours. 0.2 divided by 28.8. It comes out to be 144th or 6.94. Looks like it's reoccurring there. Might just write that as 1 over 144 for now. So that's in hours, isn't it? Okay, I don't want it in hours, I want it in seconds so I can compare it with Tom's time. So to convert that into seconds, I'm going to have to multiply by 60. That will tell me the number of minutes, and times another 60 to give me the number of seconds. So taking my answer and multiplying it by 60 and then multiplying it by another 60, that is going to give me 25 seconds. Okay, so now I can see then I've got 25 seconds for, this was Adil, wasn't it? We're doing Adil's race at the moment. We know that Adil then is 25, and we know that Tom completed it in 24 seconds then. So who's faster? It's Tom by a second, isn't it? So Tom fastest. Question 10. The mass of a baby is 3.6 kilograms to 1 decimal place. What is the error interval for the mass in kilograms? Tick one box. Okay, so when I'm doing these, I like to draw a number line and mark on the number they've given me, which is 3.6. Okay, so that's the number they gave me, 3.6 there in the middle. Right, and then it says that this number is only correct to 1 decimal place. Now, the first decimal place is the tenths column there, so 1/10 more than 3.6 would be 3.7. So that would be the next number that you could possibly round up to, and the one below it would be 3.5 on that scale. So if I'm rounding to the nearest decimal place, I'd be rounding between these numbers. If it was closer to 3.6, it'd be 3.6. If it was closer to 3.7, it'd be 3.7. So which numbers round to 3.6 then? They're going to be the ones that are halfway between those or closer. That's the zone that rounds to 3.6, isn't it? Okay, now the start of that zone is halfway between 3.5 and 3.6, which is 3.55, so that's my lower bound. Okay, and then my upper bound is going to be halfway between 3.6 and 3.7, which is 3.65. Okay, so I need the boundary that is, so for my mass, it's going to be greater than or equal to 3.55, but strictly less than 3.65, because really 3.65 rounds up to 3.7, doesn't it? So it's still the boundary, but it rounds up. Okay, so which one is that then? So it's got to have 3.55 at one end. Okay, so it's either this one or this one, but there's only one that's got the less than symbol on the other side, which is that one there. So it's going to have to be this one. Okay. Question 11. A quadrilateral has angles 70, 110, 130, and 50. Circle the possible type of quadrilateral. Okay, so is it a kite? Is it a parallelogram? Is it a rhombus? Is it a trapezium? Right, so if you're not sure about this, good to sketch them. What does a kite look like? It looks like this. A kite has opposite angles here and here that are the same. Okay, so it can't be a kite because a kite has got a pair of opposite angles there that are equal to each other. So what does a parallelogram look like then? Okay, so a parallelogram looks like this. Again, opposite angles are equal, so that one is equal to that one, and actually that one is equal to that one on a parallelogram. So it's got two pairs of equal angles. So again, definitely not the parallelogram. What about a rhombus? A rhombus is like a parallelogram where all the sides are the same. So again, it's got opposite angles that are equal. So that one is equal to that one. That one is equal to that one. So again, it cannot be the rhombus. Okay, so the only thing that's left is the trapezium. Okay, and it could very well be a trapezium. If it was a trapezium, then you would have opposite pairs that add up to 180, which you kind of do, don't you? So you've got like these two add up to 180, so you could have a co-interior pair here that sum to 180. You could have like 110 and 70 going together there, giving you 180, and the other pair over here, they also sum to 180, so you could have them here and here, let's say 130 and 50, and they'd be a co-interior angle summing to 180, which means these two lines here would be parallel, and it means that this one is the one, isn't it? It's trapezium. Question 12a. B is 6 kilometers due south of A and 6 kilometers due west of C. Work out the bearing of A from C. So we need to go to A from C. Okay, so I'm going to draw that line on because it's not currently on the picture. Okay, so using the ruler, just going to draw an extra line in from there up to there. Look. Okay, so we want to go from C towards A then, don't we? Okay, and now if we want the bearing of A from C, then we also need to have a north line drawn on C, the point we're exiting from. Okay, so that is due north, because bearings are always given clockwise from north. Okay, so the direction that we need to find, or the angle we need to find, is this one, going clockwise around to north until we get to the line or the direction we want to go in. Okay, now I know that I've turned a 3/4 angle plus this angle in here, haven't I? Okay, So if you think about it, I've gone like 90, 180, 270 to there, plus that yellow bit. So it's going to be 270 degrees plus the yellow bit there, whatever that is. Okay. Now, I suspect I already know what that angle is. I think it's a 45-degree angle because, well, I'm just used to doing trigonometry problems like this. I already know it's 45. But I'm just going to show you why. If I use trigonometry here and say this angle here is theta, okay, then again, using SOHCAHTOA, then the opposite side is this one over here, and the adjacent side is this one over here. And again, this is the hypotenuse over here that we're not interested in and we don't want. So it's another example of us using tan. Okay, so tan theta is equal to the opposite divided by the adjacent, okay, which is 6 divided by 6, which is 1. Okay, so tan of an angle is equal to 1, and I know from my exact angles therefore then theta is going to be 45 degrees, because I know that tan 45 is 1. Or you could type it into your calculator and it will tell you theta is 1. Okay, but I kind of knew that already. As soon as I saw the 6 and 6, then I realized it was a 45-degree angle. Okay, so theta is 45, and so then the bearing is going to be the 270-degree 3/4 turn plus the yellow 45 degrees, and that gives me a total of 315 degrees. Okay, now bearings are normally given as a 3-figure number, which that already is, so don't need to kind of pad it out in any way. So the bearing is 315. Question 12b. Here is a scale drawing. A ship is going to sail from D to E. Maya works out the ship needs to sail on a bearing of 068. Why must Mia be wrong? Okay. Well, I can see if I'm going from D to E in this direction, from D to E, then I want to go from here down to here, don't I? Off in that direction there. Okay. I need to put in a north line to measure my bearing from. Okay, so that if that's north there, then my bearing is going to be this angle here. Okay. Okay, so I can see already it can't possibly be 068, can it? Because 068 is kind of in like that direction. That would be 068, whereas we're going southwest, aren't we? So I'm going to say 068 is a northeast direction, whereas the boat needs to go, what's that, southwest? So we think the angle, I think the angle is going to be like, you know, so if you've got like north, east, south, west, the north is 000, east is 090, south is 180, and west is 270. Okay, so in this case, our direction is going to be somewhere between 180 and 270. So I might just put that down as well. So between 180 to 270. Okay, it's in that range, isn't it? Okay, so it's not 068. It's not in the northeasterly direction. Question 13. Simplify root 5a plus root 5a. Okay. So, you know, if we had a plus a, it would be 2a. If we had 5a plus 5a, it would be 10a. So I'm going to have to add root 5 and root 5 together. What's root 5 plus root 5? Well, root 5 plus root 5 is not 5. I'm not squaring it. I'm not timesing it together. I'm just adding them together. I'm going to get 2 lots of root 5, aren't I? So root 5 plus root 5 is 2 root 5. So root 5 plus root 5, that's just 2 root 5. So root 5a plus root 5a is going to be 2 root 5a. It's going to be that one there. Okay. Question 14. Students in 2 classes A and B raised money for charity. The box plot for class A is shown on the grid. And for class B, we're told that the lowest amount was £3, the highest amount was £26. The lower quartile was £11, the median was £2 greater than the class A median, and the interquartile range was 1.5 times greater than the class A interquartile range. draw the box plot for the class B on the grid. Okay, so to draw a box plot, we need to have 5 values. We need to have the lowest value, we need the highest value, we need the lower quartile, which is Q1, we need the median, which is Q2, and we need the upper quartile, which is Q3. Okay, so what do we know? So we know straight off that the lowest amount was £3. So I know that one, it's £3. Okay, and I know that the highest was £26. So I know that one as well. That one is 26. Okay, the lower quartile was 11. So I've just been given that one straight out. So that one is equal to 11. Equals £11. Okay. Now, the median, I'm not given straight out, but I've been told that the median is £2 greater than the Class A median. So where's the Class A median? So if you have a look on the diagram here, if you read down from the median line, that's the middle line in your box plot, you can see that that's at 12. Okay, so Q2, the median, is going to be 12 plus 2. It's going to be £14, isn't it? Okay, let's just get rid of that. And then finally, the interquartile range was 1.5 times greater than the Class A interquartile range. So what's the interquartile range for A? Well, the lower quartile is this one here, isn't it? And that is down at 9. And the upper quartile is, what's that? That's 17. So for A, so Class A interquartile range is going to be the upper quartile, which is 17, minus the lower quartile, which I read off as being 9. So that's got an interquartile range of 8. Okay, so if our interquartile range for B is 1.5 times bigger than that, then Class B interquartile range is going to be the Class A interquartile range times 1.5, then, isn't it? And that comes out to be 12. Okay, so if the interquartile range is 12, then the upper quartile, Q3, is going to be 12 higher than the lower quartile, then, isn't it? So Q3 is going to be the lower quartile, which is 11, plus the interquartile range, which is 12, which gives me the upper quartile then at 23. Okay, so now we've got all the amounts that we need. Okay, we can go on and work these out. So yeah, so this one came from there, look, and this one came from there, didn't it? Okay, so yeah, so we know what we're doing now. Let's just draw this on. So I'm going to get my ruler out and I'm going to kind of draw the values first on the graph. So lowest at 3. So how are we going to do this? I'm going to follow the same pattern as the one above, so they kind of match up. So the lower one is, I'm going to use 3 squares because they use 3 squares for their lines. Okay, so I'm just going to do it the same way. So that's my lowest value. Now then my Q1 is at 11. Now they've drawn Q1 slightly longer in the one above. They've done like 5 units, 5 little squares. So I'm going to just match the styling of the one above and also draw mine a little bit longer. Okay, and then Q2 is at 14. So 14 is about there. To draw that on. And then Q3 is at 23. Okay, and then finally the highest value is at 26, and again that was just 3 squares on the one above, so I'm just going to match the styling here as well. Okay, so then to finish it off, I just need to make my box and draw on my whiskers. So the box goes in this direction. Did you know they were called whiskers? These diagrams used to be called box and whisker diagrams, but they're rather boringly now called them box plots. I don't know why. I preferred box and whisker diagrams. I think it's quite descriptive. So there's my box. Then I'm going to draw on my whiskers. Coming out either side of the box. Okay, and that's my completed box and whisker diagram. Question 15. A town has a population density of 278 people per square kilometre and a population of 158,460. Now we're given the formula for population density. It's population divided by area, and we're told that the population increases to 168,720. Work out the population density after the increase. Okay, so the population density after the increase is going to be the new population divided by the same area. Okay, but we don't know what the area is at the moment, because in the first part we've been given the population density, this part of the formula, and we've been given the population, this part of the formula. So if we rearrange this one first, we should be able to work out the area of the town first from the bit in the first bit of information. And then once we know the area of the town, it's not going to change from one time to the next. So we're going to use the same area and the new population to work out the new population density. Okay, that's my plan. All right, so let's work out the area first, rearranging this. If I take area and population density and just switch them around like that, I should get the formula for area. So area equals population divided by population density. Okay, so my rearranged formula for finding area. So I know from the question that the population density is 278, so that's going to go on the bottom of my fraction. 278, and goes there, and then the population goes on the top. We know the population is 158,460, and that's going to go there. So 158,460. So subbing that into my calculator. What is 158,460 divided by 278? Okay, apparently that's 570. Okay, now assuming, because I divided population by population per kilometre squared, then this must be in kilometres squared. Okay, so now I know the area of the town is 570 square kilometres. I can now work out the population density after the increase. So new pop density is going to be the population over the area. Now we know that the population that was given, so population increases to 168,720, so that's going to go here, and then we're going to divide that by the area that we found here, so that's going to go there, isn't it? Okay, so subbing those two numbers in, 168,720 divided by 570, what does that give me? So 168,720 divided by 570, that comes out to be 296. So 296, what's the unit? People per kilometre square. So that's people per kilometre squared. Okay, so that's my answer, 296. Question 16. Here is a scale drawing of a reservoir. The scale of 1 centimetre represents 500 metres. Virat wants to estimate the volume of water in the reservoir. He draws a scale drawing of a circle with a radius 3 centimetres. Virat estimates the volume of the reservoir by assuming that the reservoir is a cylinder whose cross-section is a circle and the depth of the reservoir is 17 metres. Work out Virat's estimate in cubic metres. Okay, so what he's doing, he's taking this reservoir and imagine it that it's a big circle and it goes down like that and makes a kind of cylinder, shallow cylinder like that. Okay, so if he's measured a circle which is 3 centimeters across, then using our scale up here, then in reality that's going to be 1,500 meters, isn't it? So the radius of my circle is 1,500 meters. Now we know that the depth is 17 meters. Okay, so like I say, it's kind of a dumpy cylinder, not very tall. Okay, and then we're going to use the formula for the volume of a cylinder. So the volume is going to be equal to, now a cylinder is just a cylindrical prism, and any prism has formula cross-sectional area times height or length. Okay, so in this case the cross-sectional area is a circle, so it's going to be pi r squared, and then we're going to multiply it by the distance between the two matching faces, which is going to be our h, the height of the cylinder. Okay, so subbing in what we know, pi is pi, r is 1500 squared, and then h is going to be 17. Work out Virat's estimate in cubic meters. Just going to type that into the calculator then. So pi times 1500 squared times 17. Okay, so that comes out to be a lot. That's what even is that? How many digits have I got there? I make that 120 million. Okay, so to three significant figures, and I don't really need to do it any more than three significant figures, I'm going to say that's equal to 120 million cubic meters. Okay, that's a lot of water. Okay, so 120 million cubic meters. We don't have to put all the detail down. It's quite normal to round numbers off to three significant figures. So that's what I'm going to do. Right, in part B, the depth of the reservoir is 13.8 meters, and the reservoir is not a cylinder. See diagram. So which statement about the actual volume of the cylinder is correct? Tick 1. So is it less than Virat's estimate? Is it greater than Virat's estimate? It could be less than or greater than Virat's estimate. Okay. Right, so what's going on here? So the actual depth of the reservoir is clearly less than what we used, because before we had 17 and now we've got 13. So that one has been reduced. Okay, so if I'm working on volume is equal to pi r squared h, then what we've done here is we've reduced the value of that height then, haven't we? It's gone from 17 to 13.8. So that would put a downward pressure then on the actual volume of water in this reservoir. It's going to be less than the estimate. However, you can see here that the actual cross section of this reservoir is actually a lot bigger than the circle that we measured. Okay, so this bit is actually less, but this bit, the circle, is actually more. Okay, and it's going to be the interplay of those two that's going to determine whether or not Virat's estimate is high or low. And from the information that we've been given, it seems unclear about which of those two scenarios it's going to be. So I'm going to say it could be less or greater than Virat's estimate, and the reason is cross-section has increased, but depth has decreased. Okay, so that's the reason. Okay, because one's gone up and one's gone down, and it will be the relatively size of those changes that will determine whether or not overall the volume increases or decreases. Question 17. In a video game, players can make their own character. They choose one of each from 8 faces, 4 bodies, and 5 hairstyles. How many different characters can be made? Okay, well, the number of different choices is going to be, for each of your 8 faces, you've got 4 choices for your body and you've got 5 choices for the hairstyle. So if you just multiply those all together, then you'll get the number of choices all together. So 4 5s are 20 times 8 is 160 different characters. Okay, so the answer is 160. 2 characters are made at random. What is the probability that they are exactly the same? Okay, so if you've got 160 characters and you select 2 at random, then you've got 1 chance in 160 of picking any one individual character. Now, the probability that you've got 2 the same, well, let's say you've made one. So given that you've already made a character, what's the probability of them making another character which is exactly the same? So what you're essentially doing here is saying what's the probability of picking a particular character given that you've already picked that same character, okay? And the probability of that then is just 1 in 160 then, isn't it? Okay, so it's just 1 in 160 because you're given that you've already made one before you then work out the probability of then building another one just like it. Okay, so it isn't 160th times 160th, it's just 1 over 160. Question 18, A, B and C are points in a circle, centre O. DC is a tangent to the circle. Show that the ratio of angle ABO to angle ACO is in the ratio of 3 to 1. Okay, well, all sorts of things going on here. So we need to find angle ABO at some point, which is angle ABO is this angle here between these two, so it's going to be that angle there. We want that angle, okay, and we want angle ACO. So angle ACO is there, down there, and down there. So we need to know that angle there as well, okay. So we need to find those two angles, and we need to show that they are in the ratio of 3 to 1, okay. But how are we going to do that? Okay, well, first off, what do we know? We know this angle up here, 28, and we know this angle down here. Now, I don't really focus too much on what the problem is asking me first off. I just think about, well, what I've been given and what can I find, okay? So let's take that so that 83 degree angle there on the tangent, okay? So using the alternate segment theorem, I know that the angle between a tangent and a chord drawn at the point of contact, which is this 83 degree angle here, is going to be the same as the angle subtended in the alternate segment. So if I were to draw two lines coming off of that, then that angle up here, then that's going to be the same as 83, okay? And that's because of the alternate segment theorem. So that angle there is 83, okay? So we know that, what's that, angle ABC. So angle ABC is equal to 83 degrees, and the reason for that is the alternate segment theorem. Okay, now this is a show that question, so you need to give reasons for your statement. So you can't just find angles, you've got to give reasons as well if you're going to get all these marks. So I know that angle ABC is 83. Okay, what else do I know? I know the angle at the center, don't I? So I can look at that 28 and I can use it to find this angle down here then, because I know that the angle subtended at the center is twice the angle at the circumference. So that tells me then that angle BOC is equal to 2 lots of 28, which is 56 degrees. And the reason for that is angle at center is twice angle at circumference. So for the paper, it's good to memorize these little statements for each of the various rules that you need to know about, because for the show that questions or the proof questions, you do need to justify your reasoning. Okay, so angles at the center is twice the angle at the circumference. So I know that BOC is 56, so I've got that one, it's 56. Okay, and I know that one, it is it's 83, and I know that BOC is an isosceles triangle, isn't it? Because OB and OC, they are both radii. Okay, so that is a radius and that is a radius, so they're both equal in length. So I can say triangle BOC is isosceles. Okay, so therefore angle OBC, so angle OBC is going to be equal to angle OCB. Okay, those two base angles then like there and there, are going to be equal to each other, aren't they? And they are going to be 180 minus the angle at the top, minus the 56, divided by 2. Okay, so I'm taking the 56 away from 180, and then I'm sharing what's left between those two base angles. So 180 minus 56, what's that then? That's 124, and divided by 2, that's 62 degrees then, isn't it? Okay, so that one is 62 and that one is 62. Okay, so feeling like we can now at least find one of our angles. We can find ABO then, can't we? Because I know that ABC is 83, and I know that BOC is 62. So if I take one away from the other, it's going to leave me with ABO. Okay, so angle ABO, which is one of the ones I wanted to find, that's going to be angle ABC, which I already found, minus angle OBC, which I just found. Okay, so that is going to be ABC was 83 from up here, look, that was 83, and then OBC, going to take away OBC, which was 62, okay, which we found over here, so that's that one there, so 62 there, look, okay, or there. Okay, so then that leaves me with what? So ABO then is going to be 83 minus 62. That leaves me with 21 degrees. Okay, so I know that ABO is 21 degrees. So now I need to find ACO. How can I find that then? Well, I guess I know two angles in the triangle ABC now, don't I? I know that the one at A and I know the one at B. So I can use that to find the angle at C then. So let's do that. So in triangle ABC, then I can work out angle at C. I can work out ACB, that angle down there, because I know it's going to be 180 minus the other two that I know. So it's going to be 180 minus ABC, which I've already found, and the other one, which is ABC and BAC, isn't it? Plus BAC. So adding those two angles together. Sorry, that 5 marks was a little bit annoyingly in the middle. So that's going to be 180 minus angle ABC, which was 83, and then angle BAC, which was 28. So if I add those together and take it away from 180, what's that? 83 and 28, that's 103, 111. 111 from 180 makes 69. That's 69 then. So that's 69 degrees. So then I can then work out what ACO is then. So now I can work out ACO. ACO, that's going to be the angle I just found, ACB, minus that angle in the triangle OCB that I found earlier. Okay, so ACB minus OCB, that is going to be ACB we just found to be 69 degrees, and take away OCB that we found earlier, which was 62 degrees, and that leaves us with 7 degrees. Okay, so I now have angle ABO, it's over here, look, it's 21, and I've got angle ACO, found that, that's 7. So now I can say that ratio of angle ABO to ACO, so ratio ABO to ACO of those angles is going to be 21 to 7, which cancels down to 3 to 1. Okay, so I got the 21 from earlier there, and I've just worked out the 7, and that cancels down to 3 to 1. So I've shown it, haven't I? Question 19, here is a plan of the floor of an L-shaped room, all lengths are in meters, and it's not drawn accurately. We're told that the area of the floor is 75 square meters. Show that x squared plus x minus 90 is equal to 0. Okay, right, so we can divide this up into two separate areas, I guess, and then so we can then combine their areas using a little bit of algebra. All right, so I'm going to divide this up into two little squares. I think I'm going to do it that way. You could do it either way, really. It's going to come out the same way. I don't really know why I'm picking this one. I think it might be slightly easier to do it this way. I don't really know. Okay, so that little rectangle at the top, so the area is going to be equal to my two areas, area 1 plus area 2. So that's area 1 and that's area 2. So area 1 is going to be 3 lots of x minus 5, isn't it? I'm just taking this and multiplying it by that. Okay, so 3 times x minus 5, and that's going to multiply out and give me 3x minus 15. Okay, now A2, what's that then? A2 is going to be this x in this direction multiplied by x minus 2 in that direction. So I'm going to get an area of x minus 2. I mean, I think that's the reason I did it this way. Otherwise, I was going to get a quadratic that I need to multiply out, and this way I only have to do single bracket expansion, so it looked a bit easier to do it this way. So x times x is x squared, x times minus 2 is minus 2x. Now if you did it the other way, it will come out the same, as you just made your life a little bit harder, because you're going to have to multiply out a double bracket. Right, let's collect like terms together. Let's bring the x squared to the front, and I've got 3x minus 2x, that's x, and I've got minus 15, and we're told that that is equal to 75. Okay, so we know that that's equal to 75. So I can say that x squared plus x minus 15 is equal to 75. Okay, so then let's just bring the 75 over to the other side. I'm going to get x squared plus x minus 90 equals 0. Okay, which, so it's shown, isn't it? Okay, so I've done that bit now. So I've got x squared plus x minus 90 is 0. Now part B wants me now to factorize x squared plus x minus 90 to work out the value of x. Okay, right, now does it factorize? I hope it does, because I don't like the formula. So let's hope it goes into two brackets like this. Now if it does, I'm going to have an x and x at the front, because my x times the x is going to give me my x squared. Right, now the 90 at the back, the minus 90, I'm going to get when I multiply those two numbers together. So what are the factor pairs of 90? What are the possible pairings I could get? I could have 1 and 90, could have 2 and 45. 3 goes into 90 30 times. What about 4? 4 doesn't. 5 does. 5 and 18. 6, yep, 6 goes into 90. 6 goes into 19 15 times. Any more? 7, nope. 8, nope. 9, yep, 9 times 10. And I kind of met myself coming down the other way there. So I've got all my factor pairs. I've got a lot, haven't I? Okay, but I know that the pair I'm looking for are going to have to be quite close together. They're going to have a difference of 1. Okay, so I'm pretty sure it's going to be this pair here, because they've got a difference of 1. And it's a positive difference, which means the bigger number has to be the positive one. So it's going to be x plus 10 here and x minus 9 here. Okay, so then my x times the x gives me x squared, the 10 times x gives me 10x, and the x times 9 gives me minus 9x, and they combine together to give me plus x in the middle. And then finally I've got the 10 times 9, and that gives me the 90 at the end. Okay, right, so it all kind of works out, but I haven't quite finished yet, have I? Because I know that this is equal to 0. Okay, so I need to carry on and finish this off then. So x then is going to be equal to minus 10, or x is equal to 9. Okay, now those are two solutions to this particular quadratic equation, but this one here cannot be a solution to my problem. And the reason for that is, if x was negative, then I would have a length on my original diagram that had a negative value, and that does not work in our kind of universe, does it? You can't have negative lengths. So because this problem stems from a real life situation with real life lengths, then that solution, even though it's a solution to the quadratic, is not a solution to this problem. So that one is not a solution. Okay, so the only solution that is viable is x is equal to 9. Question 20, £2,448 is invested in an account at a rate of compound interest. 1 year after the investment, there is £2,496.96 in the account. How much is in the account 4 years after the investment? Okay, so there are 2 steps to this problem. The first thing we need to do is work out the rate of interest that's being applied to the account. Now we've got like the before and after of the first year, haven't we? Okay, so from that we should be able to work out the percentage change for 1 year, and once we know the percentage change from 1 year, then we can apply it 4 times to find how much is in the account after 4 years. Okay, so coming back to my triangle, final original multiplier, used it earlier, FOM, stick your thumb on it, just going to work out what F is, what O is, what M is. Okay, so the multiplier, really, and that's the thing we're trying to find here, isn't it? That is the percentage written as a decimal, and in this case, that is going to be the rate of compound interest. That's what we want to find. We want to find out what the percentage changes every year. Okay. Now, what is the final and what is the original? The original is the amount of money that started off in the account. That's going to be the 2448, isn't it? So 2448, that's what we need to find. So that means that the final amount after the percentage changes happened is 2496.96. So that's going to be 2496.96. Okay, so we cover up the thing we want to find, which is in this case is the multiplier. And then so we can use multiplier is equal to final divided by original, which is 2496.96 divided by 2448. Okay, what does that come out to be? So 2496.96 divided by 2448, that comes out to be 5150 or 1.02. Okay, now I'm just going to leave that as a multiplier because we need to go on then and do this, don't we, a number of times. Okay, so now we want to do a compound interest question where what we've got, final, original, multiplier and years. Okay, we have to add an extra one on for this one. So the final is what we want to find. We want to find how much money is in the account after 4 years. The original is still going to be what it was a minute ago. It's going to be 2448. The multiplier is going to be what we found. It was 1.02. It's a 2% increase per year. And then the number of years that we're running for, that is going to be 4 years, isn't it? It's from the question up there. So that is going to be 4 years. Okay, so then the final then, I forgot to put the values in, FOM. So I want the final in this case. So you cover that up with your thumb. It tells you what to do with the other 2. Final equals original times multiplier. So final equals original times multiplier. Now, because this is a compound interest question, we also then just raise that to the number of years, okay? Because we're going to apply that multiplier a number of times. Okay, so the original was 2448. The multiplier is 1.02, and the number of years is 4. Okay, so it's going to be 2,448 times 1.02 to the power of 4. So let's type that in: 2448 times 1.02 raised to the power of 4. That comes out to be 2649.79 and change. Okay, I'm just going to round off to the nearest penny. So that's 2649.79. Okay, and that's my answer. £2,649.79. Question 21. Use the sine rule to work out the size of angle X. Okay, so the sine rule we can write either way up. We can either write it with the angles at the top and the sides at the bottom, or we can write it with the sides at the top and the angles at the bottom. Okay, either way, we tend to label sides and angles opposite each other. So if this was angle A, the one I want to find, then this would be side A over here. That's the side I've been given. Okay, and then I'd make this one maybe B, and then so this would be side B, and then C, which I don't really care about, is up there, and side C, which I don't really care about, is down here. Okay. Now, sine rules is about opposites, it's about opposite pairs. So you can see you've got angle A, and that goes with side A, and I've got angle B, and that goes with side B, like that. All right. And I've got C and side C that I do not care about. Right, so then we're going to write out 2 out of the 3 parts of the sine rule. So I want the bit with A in, I want the bit with B in, I don't care so much about the bit with C in it, okay? I'm going to write it down with the angles on the top because I want to find an angle. So I'm going to write down sine A over A is equal to sine B over B, like that, okay? Then subbing into my formula, A is actually x in my problem, isn't it? So that's sine x, and that's over side A, which is 17, and that is equal to sine B, sine 64, divided by side B, which is 23. Okay? So just rearranging that so I get sine x by itself. I'm just going to multiply through by 17. It will move that 17 from down there up there, won't it? Okay, so that's going to give me sine x equals 17 sine 64 divided by 23. Okay, so then I can just tap that into my calculator and use the inverse sine button to find x. So then x is going to be equal to, so I'm going to type into my calculator shift sine. I'm going to use the fraction key. So I can then put 17 sine 64 on the top. Okay, close bracket there. And then I'm going to go down, and underneath I'm going to write 23, and I'm going to press right, and I'm going to close the bracket. So the inverse sine of 17 sine 64 over 23. And for me that comes out to be 41.6 degrees to the nearest tenth of a degree. So 41.6 degrees. Question 22, f of x equals 3x and g of x equals x squared. Circle the expression for fg of x. Okay, now with function notation, you always start in the middle. So I'm starting with g of x, and then I'm taking g of x and I'm subbing it into f of x. Okay, in other words, I'm going to take x squared from here, and I'm going to write it where I see the x here in f of x. Okay, so my fg of x is going to be 3, but rather than writing x, I'm going to write the expression for g of x, which is x squared, and that's just going to give me 3x squared then, isn't it? So it's that one there. Question 23. Here are 2 simultaneous equations. We've got y equals x squared plus 7x minus c, and y equals 3x plus d. There is a solution when x equals 5, work out the value of c plus d. So we've got 2 simultaneous equations. One is a quadratic, so it's going to look like this, and one is linear. So there are potentially 2 solutions. There might be one if it just kind of touches the curve, but we don't know that yet. We know that might be potentially 2. Okay, so we think one of them is going to happen at 5. So what does that tell me then? It means that one of these point of intersection here or here, x is equal to 5. Okay, now we would find those point of intersection normally by subbing one of those equations into the other one, wouldn't we? Okay, so can you see I've got y is equal to this expression and y is equal to this expression. So if I call this one equation 1 and this one equation 2, then I can substitute equation 2 into equation 1. Okay, and so I'm going to take what this is worth here, what this is y is worth, and I'm going to equate it with what this y is worth here. Okay, so I'm going to write down 3x plus d, that is what y is worth from equation 2, and I'm going to equate it with what y is worth from equation 1, so x squared plus 7x minus c, like that. Okay, so I'm solving by substitution. That's the green bit, that's the blue bit, and I substituted in for y, so y has disappeared. Okay, so then we can kind of just move this all over to one side, I guess. So we can make it all equal to 0, can't we? Let's collect on the right, keep the x squared positive. So that's going to be equal to x squared. 3x taken away from both sides is going to give me 4x. D taken away from both sides is going to be c plus d, like that. I could group them together that way. I could write minus c minus d, but I'm kind of matching this form here with what I've got over here, so I think that might help. Anyway, so right, so what have I got? So I've got this is equal to 0. Now I'm told that there is a solution for this when x is equal to 5. Okay, so this is true when x is 5. Okay, so when x is 5, what does that give us then? So that tells me that 5 squared plus 4 lots of 5 minus c plus d, that's going to have to be equal to 0 then, isn't it? It's going to have to be true, okay, for that point there. So what's that then? So 25 plus 20 minus c plus d is equal to 0. So 25 plus 20, that's 45. And then taking my c plus d, which is negative one side, and bring it over to the other side, I get c plus d is equal to 45. Okay, and I think that's just my answer, isn't it? C plus d is 45. Question 24. Here is a sketch of the graphs y equals k to the power of x and y equals x squared plus c. K and c are positive constants. So yeah, we've got them drawn on here. We've been given a point that lies on the exponential function here, and we've got a point that lies on the quadratic function here, and we've got a partial point given us for the point of intersection between the two. Okay, we know that the x coordinate is 2, we don't know the y coordinate right now. Okay, but we need to work out the value of r. Where's that? That's like the x coordinate of that point over there. So how on earth are we going to do this? Now let's start with y equals k to the power of x. Okay, for y equals k to the power of x, we know a point it passes through. It passes through 481, doesn't it? So we know it passes through 481. So we could take those two values, so we could sub it in, and then hopefully we'll know what k is after that, because k will be the only thing that we don't know. So it passes through 481. So subbing in 81 for y, 81, and we sub in 4 for x. So 81 equals k to the power of 4. Okay. So what could k be then? Well, k could be either negative 3 or positive 3, couldn't it? So because 3 times 3 is 9, times 3 is 27, times 3 is 81. Okay, so k is going to be plus or minus 3. Okay, there's two possible values of k there. I don't know if that is a problem or not. Well, actually, I just read that k and c are positive constants here, so it can't be minus 3. It's going to have to be, k has to be plus 3. Okay, so we know that k is 3. That makes things a bit easier. Okay, so k is 3. So therefore, the equation of the exponential function is y equals 3 to the power of x. Okay, so now we've got the complete function for that one. Now we know that these lines intersect at the point 2p, and I've got the equation of the exponential function now, so I should be able to find out what p is. Okay, so we also know that it passes through 2p, so that 2p is a point on the line. So if I sub those two values into the function, then it should be true. So p, the value of y, should be 3 lots of x, 3 lots of 3 squared, isn't it? Okay, in other words, p is equal to 9. Okay, so that point there is actually the point 2, 9. Okay, so now we're doing quite well now. So now we've got a point that lies on both lines. So I can switch over now my focus to the second line, y equals x squared plus c. So for y is equal to x squared plus c, we know that the line also passes through that same point, because it's a point of intersection, so it passes through 2, 9. Okay, so then subbing those two values in, then I know that 9 is going to be equal to 2 squared plus c. So what is the value of c? C must be 9 subtract 2 squared, 9 subtract 4, C is going to be equal to 5. Okay, so therefore we now know the equation of our quadratic. So therefore equation is y is equal to x squared plus 5. Got the complete equation now. And now we've got the complete equation, we can then go on to find r finally, after all that jiggery pokery. So we know that this line passes through r comma 43.44. So subbing those two values in, so 43.44 is equal to r squared plus 5. Okay, so what does that mean? So 43.44 equals r squared plus 5, taking 5 away from both sides, that means r squared is equal to 38.44. So then r is going to be the square root of that. So 38.44 rooted is 31 over 5 or 6.2. Okay, so r is 6.2. And that's my answer. Work out the value of r. It's 6.2. That's quite long, isn't it? Question 25. A company makes tubes of toothpaste. The masses of 80 tubes are checked and the histogram is drawn to represent the data. So we've got frequency density up the side and we've got the mass in grams along the bottom. The company makes 28,000 tubes each day. Estimate how many tubes each day have a mass less than 122 grams. Right, now we know that there are 80 tubes represented in this diagram. So we know that the total area of all these bars added together is going to be 80. Okay, now what we need to do then is work out what fraction is less than 122. Okay, so 122 is going to be there, isn't it? Okay, so we want the area of the graph, which is to the left of that line there, that area there, plus that area there, those two areas added together. Okay, so what are the areas of that then? So if I call that one area 1 and area 2, then area 1 is going to be, well, it's got a class width of 120 minus 110. It's got a class width of 10 and it's got a frequency density of 0.6. So if I multiply those together, that's going to give me the frequency. So frequency is going to be frequency density times class width. Frequency equals frequency density times class width. I've actually done it the other way around here, but anyway, same thing. So that gives me a area of 6. So that purple bar represents 6 people. Okay, and now the green bit of the second bar, that is going to be a class width of 120 to 122. That's 2 times a height of 4. So that represents another 8 people. So altogether there are, well, not people, it's tubes of toothpaste, isn't it? So that means overall there are 14 tubes of toothpaste that are less than 122 grams. Okay, so I've got 14 tubes less than 122 grams. Okay, so what fraction of all the tubes then is that then? So as a fraction, I've got 14 tubes out of a total of 80 tubes that are underweight. Okay, so if I take that fraction and I multiply it by the total number of tubes that the company makes each day, then I should find the fraction that is going to be less than 122 for the whole day then, isn't it, as an estimate? Okay, so my estimate is going to be my fraction, 14 over 80, it's going to be the value I found here, the 14, divided by the total number of tubes that they gave me, times by the total number of tubes made in one day. Okay, so what's that then? So that's 14 divided by 80 times by 28,000. And that comes out to be 4,900. So I'm estimating 4,900 tubes are going to be underweight. Question 26. Q and R are two numbers. As a product of prime factors, Q equals 2 cubed times 3 times A cubed, and R equals 2 to the power 4 times 3 squared times a squared. The highest common factor HCF of Q and R is 4056. Work out the value of A. Okay. Now, the HCF is all the kind of common prime factors multiplied together of your two numbers. So I'm just going to write this out in long form. So Q is 2 times 2 times 2, 2 cubed, times 3 times A cubed, which is A times A times A. So I'm just going to write out an expanded form. R is equal to 2 times 2 times 2 times 2 times 3 times 3 times A times A. Right, so what do they have in common then? What's in both? Okay, so I've got a 2, a 2, a 2, a 3, an A, and an A in common. Okay, I've got some more A's, some more 2's, some more 3's, but there isn't one in the other one to pair it up with. Okay, so then the HCF of these two numbers then is going to be all those prime factors multiplied together. So it's going to be the 2 times 2 times 2 times 3 times A times A, and we know that's equal to 4056 because it told us in the question. All right. Right, so then just simplify this a bit. So 2 cubed times 3 times A times A. 2 cubed is 8 times 3 is 8, 16, 24. And that's 24A squared equals 4056. So dividing through by 24 and then square rooting. So 4056 divided by 24, that's equal to 169. And then root answer. That's 13. So that tells me then A is equal to 13. Okay, so A is 13. Right, work out the lowest common multiple LCM of Q and R. Okay, so what's the lowest common multiple now? Now, the lowest common multiple of two numbers is every base that appears to the highest power that it appears. Okay, so we've got a 2 and a 2 in Q and R, but the highest power is going to be the 4. Okay, we've got 2 to the cube, 2 to the 3, and 2 to the 4. So the highest power is going to be 2 to the 4. And then we've got a 3 and a 3 in Q and R. I've got 3 to the 1 in Q, but I've got 3 to the 2 in R. So it's every base that appears, 3 to the highest value that appears. It's going to be a squared. And then we've got an A and an A in Q and R, but the highest power there is the Q power. Okay, so then it's going to be A cubed, but A we worked out to be 13, so that's going to be times 13 cubed then. Okay, so the LCM is 2 to the 4 times 3 squared times 13 cubed. Okay, well, I'm not going to do that in my head, I'm just going to work out 2 to the power of 4 times 3 squared times 13 to the power of 3. That apparently comes out to be 306,368, so it's a big number. So 316,368. I hope none of you were just sitting there trying to do multiples until you got there, because you're going to be sitting there a long time. Okay, but we went fast. 316,368. Question 27. Expand and simplify fully x minus 3 times x minus 4 times x plus 8. Okay, right, so I've got triple brackets here. I'm just going to write out again down here. So x minus 3, x minus 4, x plus 8. Okay, now you can't really do 3 brackets all at once. You're just going to have to pick 2 brackets and multiply them out first. And then whatever you get, then you multiply it by the third bracket. So I'm going to start with these two, and I'm going to do FOIL on here. So first inside, outside, last, or 2 eyebrows, a nose, and a mouth. And I'm going to get what I get from multiplying those out. So I'm going to get x times x, which is x squared. I'm going to get minus 3 times x, which is minus 3x. I'm going to get minus 4 times x, which is minus 4x. And I'm going to get minus 3 times minus 4, which is plus 12. Okay? So that's what I'm getting from multiplying out my 2 yellow brackets. And then I've still got the green one here. I haven't done anything with that yet. So that's just sitting at the end now to deal with in a minute. Okay? But before we deal with that one, let's just tidy up the yellow bit first. So that is going to give me x squared minus 7x plus 12. Okay, and then I'm timesing that by x plus 8. All right. Right, so then we're going to multiply everything in the big bracket with everything in the small bracket. I'm going to start with the yellow bracket and I'm going to times it by x first. So I'm going to times those three expressions, those three terms by x first. So x times x squared, that's going to give me x cubed. Minus 7x times x, that's minus 7x squared. And 12 times x, that's plus 12x. Okay, so I've done that, and then that gives me that row there. And then I'm going to do the same thing. I'm going to multiply it through by 8 this time. But a bit of a trick. What I'm going to do is I'm going to come down a line and I'm going to kind of indent a bit because the first one, 8 times x squared, that's going to give me 8x squared. And I'm going to write it here under the 7x squared, okay, because then it kind of lines up and then I can just add vertically to come up with my answer in a minute. So I'm going to drop down a line and come over here a little bit. It's just a top tip. So x squared times 8 is 8x squared. 8 times minus 7x minus 56x. And then 8 times 12. 8 12s are 96 plus 96. Okay, so that's what I got from multiplying out the purpley bit with the yellow bracket. Okay. Right, so once I've done that, then I can kind of add up then vertically. So adding up my first column kind of here, look, well, I've only got one number in it. So it's just x cubed. So x cubed. And then my next column, these two I'm going to add together. 8x squared minus 7x squared. That's just x squared. So I'm going to get plus x squared. Okay, and now my next column is here, look, 12x minus 56x, that comes to minus 44x, okay, and then finally I've just got like a column with one number in it again, it's just got a 96 on the end, so I'm just going to say plus 96 at the end. And there we go. That's our cubic that we get from multiplying out those three brackets. X squared plus x squared, so x cubed plus x squared minus 44x plus 96.
You can find more exam question compilations over here. For more past paper walkthroughs, click down here. If you want to visit my Amazon shop with my recommendations for calculators, revision guides and other maths related stuff, click down here. Good luck in your revision and in your exams, and see you again next time.